Okay, here's our second example. This is the one where we've been asked to find a reaction. So for this question, it's a verb or a written question. It's a word problem. They haven't drawn anything, so they're expecting us to draw this. So there are two forces in the XY plane acting on a point. The first is 2 kilonewtons and is at 7 degrees from the axes. And the second is 5 kilonewtons and is 120 degrees relative to the axes. Find the reaction required to keep the system in equilibrium. So we know that we have an axis system like this. And we have some object here that we want to stay still. To stay still means it's in equilibrium. There are two forces acting on this. The first one is F1, and it equals 2 kilonewtons, and it was acting 70 degrees from the x-axis. And F2 equals 5 kilonewtons, and this is 120 degrees from the x-axis. So now they've asked us to not only find the resultant, but the reaction to that resultant. So the first thing we should probably do is break this down a little bit. So let's start with F1. We want to break F1 down into its x and y components. So let's redraw F1 equals 2 kilonewtons, and we want our F1y, and we want our F1x, and we know that that is 70 degrees. So F1y is going to be F times the sine of our angle, and F1x is going to be F times the cos of our angle. Opposite, adjacent, that tells us how we break this down. Our F1y is going to be 2 times the sine of 70 degrees, and our F1x is going to be 2 times the cos of 70 degrees. We can solve this and we get F1y equals 1.88 kilonewtons. Here's where I'm just going to draw myself a little arrow, reminding myself that it's acting downwards. You might also say that this was minus 1.88 kilonewtons because it's acting downwards. This is all about context. It's all about knowing what direction we're acting here. We are inferring that because the arrow is going downwards, it's going in the negative direction. We solve our F1x and we get 0.68 kilonewtons. And it's going in that direction. Well, that direction is what we have said is negative. So I could also say that this is a negative 0.68 kilonewtons, just to help myself keep track of how we're going to add things up. Let's take a look at our F2 now. We can draw our little arrows here, and if this is 5 kilonewtons, this is our F2y, this is our F2x. We don't know what that angle is, but we know that that angle was 120 degrees. We want to know what this is relative to the x-axis, and going all the way around is 180 minus 120. Our angle here is 60 degrees. So now we know what our angle is. We can solve this for our F2y is F2 times the sine of our angle, and F2x is F2 times the cos of our angle. We know these values is 5 kilonewtons times the sine of 60 degrees, and 5 kilonewtons times the cos of 60 degrees. We can plug this into our calculator, and we get that F2y is 4.33 kilonewtons. Again, it's acting downwards. So anything downwards, I'm going to call negative. And our F2x, when we plug this in, equals 2.55 kilonewtons. I'm just going to draw myself a self-check arrow. It's going in that direction, which really means it's going in the positive direction. So now we have an idea not only what the x and y coordinates are, but what direction they're going relative to a global system. So now let's sum up all the forces in the x direction. I always just like to remind myself that anything in that direction is positive. So you'll often see this symbol right here where I've got an arrow showing what direction is positive and that I'm summing up all the forces in that x direction. Well, up here from fx1, I had 0.68 going in that direction, so minus 0.68. And over here, I have 2.55 going in that direction, so positive direction. I sum all of these up, and I get 1.87 kilonewtons. I can do the same thing in the y direction. I'm going to remind myself that everything going upwards is in the positive direction. I had F1y, which was acting downwards, and it was 1.88. And then I had F2y, which was also acting downwards. I can sum those up, and I get minus 6.21 kilonewtons. I can redraw this now. Here's my global system. I have something that is going downwards for y and this way for fx. So let's just draw our x and y components to help us draw what our resultant is. That's our total F. We know that this was 6.21. See, the arrow's pointing it downwards. I don't have to add the negative again, but I know that if I don't draw this arrow, I need that negative to tell me what direction it's going. And that this was 1.87. So now, I should always write my units. Now we want to know what this angle is right there. Again, we always want to know what our angles are. Let's use that as our angle symbol. We know that we need to find the resultant and what the angle is. We know our force is the square root of the sum of the squares. These are absolute values because once you square it, you get rid of any negative symbols. And this is a total value, so that makes sense. We plug the square root of 6.21 squared plus 1.87 squared, and we get 6.49 kilonewtons. And now we need to find out what its direction is. Opposite, adjacent. We know that the tangent of the angle equals our opposite, or our Fy, divided by our adjacent, or our Fx. So our angle is going to be the inverse of our tangent of Fy, which is 6.21, divided by our Fx, which is 1.87. We can plug this into our calculator, and we get 73.24 degrees. So now we know that we have a force acting on this object that is 6.49 kilonewtons, and our angle is 73.24 degrees. But they asked us for the reaction. We need something that is equal and opposite. So we need something that is 6.49 kilonewtons, 73.24 degrees from the other side of the x-axis. One of the things that I just want to take a second and point out is that also means that if this was our y component and that was our x component, look at this. This can also be broken down as that being the resulting y component that is equal and opposite, and this can be broken down into the resulting x component that is equal and opposite. So we can break it down, we can actually find the reactions within our x and y component if we wanted, and then solve directly for that. So that's an option of what we could do too. So that's how we solve example 2.